We are on the sections 3.2 and 3.3. We are going to do more apps on your page 51. Okay, so let's do some percentage and mixture problems. Where did you find you need to use percentage, percent? What do you think? Like you get a discount in the store, right? By percentage. Or when you buy a car, buy a house, you need to pay what? Interest rate, right? Also, if you use credit cards, you need to pay the interest as well. Or you are a real estate broker, that's how you earn your commission. Or you sell cars, you get commissions by percentage, right? So we use the percentage quite a bit. Then let's see how we actually calculate them. In your arithmetic class, okay, so we did a percentage, something called the percent proportion. Let's see what does it mean. Okay, so if you buy a pair of jeans, say $50, then it gives you $10 discount. How much percentage is that? Or if they say give you 15% discount, how much you can, for the discount. That's how we look at it, is this way. Okay, it's the amount you pay for it out of your base total. That would be your percentage out of 100. So your base is what? Total 100%. Then percentage is portion you take a discount with, right? Then here, base total dollars will be your 100% compared, to the whole thing. Then A would be your portion of the base, become portion of the 100. That's how we make the equivalent equation for it, right? For the concept of percent proportion, portion of the percent, right? Or we use the equation to show it is what? This way. Amount is percent times the base. So percent is your portion of it, right? Portion times the whole thing is the portion amount regarding to your total base, right? So we have these two equations we can use, okay? One is by proportion, two portions are the same, 100% or out of the base total. The way we do the calculation is this way, which we talk about in your arithmetic class, but here we just do a quick review, okay? Say the number 22 is what percent of 40? Say it gives you super discount, okay? And for $40, it gives you $22 discount. What kind of percentage they actually give to you? So percent of something is out of 100, but here is out of 40. Okay? So we can use either way. Then for the first formula, okay, we can say we use it to find A or B or P, okay? Because you have three things, you have to find one of them. You will be given two of them, then find the remaining one, okay? Then this one is used to find A only, because B, it's easier, just multiplying. That's how we use them, okay? So for this one, 20 is what kind of percentage of 40? So it's easier if we write it this way. Total, we have three variables, P and B and A, right? Say percentage of B. So percent times B equals your A, right? So we write the PBA, this one. Then you decide which one you don't have. You need to find it. So do we need to know the percent? Yes, it says what percent, so we don't know. Then it says 22 and 40, you have to decide which one is your B, which one is your A. B is the total base. So 22 out of 40, so total would be what? 40. Then your amount is what? 22. So you identify your PBA first, then you can plug in to find the answer, right? So we want to find the percentage. Then we need to use, easier to use the first one. So let's see. So your A is 22, B is 40, then equals, you don't know your P out of 100, right? Then how are you going to find your P? Let's review proportion again. That's how we find it. Is 1/2 equals 2/4? Right, those are half. Is 1/2 equals, say, 5/10? Is 2/4 equals 5/10? Yes, both are halves, right? When they are proportions, you find out 1 times 4 is 4. 2 times 2 is 4. Are they the same? Then 2 times 5 is 10. 1 times 10 is 10, right? 4 times 5, 20. 2 times 10 is 20. So when you have two fractions are the same, we call them a proportion. When you have a proportion, two portions are the same. When you do the cross multiplying, you should get the same number, okay? Or we say it's hot dog method, like a hot dog, right? So this way you can remember the method we are using. It's called formally cross multiplying to solve situation, because you have a proportion. When you cross multiply, you should get the same answer, right? So I have a proportion here, then I need to find the P. How should I do it? I do the hot dog, right? So I will have 40P equals 22 times 10. 100 will be 2200. So you will change a proportion to an equation. Then linear equation, you can solve it, right? So P is what? 55%. That's how we solve it, the percent problem. Okay, so first you write the proportion, then you use the hot dog method, then find your percentage. Or you find your A, or you find your B. Okay, second one, the number 150 is 40% of what? That was the question, right? So do your table. You need a P, you need a B, you need a A, right? So you know it's a 40%. Then you have to decide which one you are going to find, B or A. Then 150 is B or A. So 150 is 40% of what? 40% of a total. After off usually is the total thing we are talking about. So what is the total? You don't know. 150 actually is what? Your amount. That's how we identify them first. So you need to do that. Okay, then you can write your proportion. So A over B, 150 over B equals what? P is 40% over what? 100, right? Then we can do our hot dog. We have what? 40B equals 15000. 1, 2, 3, 3 zeros, right? Then you divide it by 40. So your B would be 375. So that would be your answer. Okay? So if you list the table like this, PPA, that would be easier for you to identify them. All right. So, next one, find the percent of increase and the percent of decrease. First problem, if a company had 200 employees last year, and this year they have 120. What was the percent of the decrease of the workforce? Say, you know, a big company, 200, now only 120. What should we do for the percent of decrease so they can budget accordingly next year for everything, right? So their expense, like say, okay, 20% decrease, 30% decrease. So their budget will reduce for everything like health care, you know, transportation, all that. So they want to find the percentage of decrease of the workforce. So we do the same thing, identify our PBA. So it was 200 down to what? 120. So find the percent of decrease. How many actually decreased? Actually 80 people less, right? We want to find the percent, so we don't know the percent. Then what's your B, what's your A? B is the total. Out of how many people? Total 200. Then what is your A? Is your A 120 or 80? You need to decide. For the decrease, not 120 decreased. It's 120 remained, so actually it's 80 decreased, right? Then how do you find your percentage? Just use this. Write A over B, 80 over 200 equals what? P over 100, right? Then we use our hot dog method. So what do we have? 200P equals 8,000. Then you divide it by 200. Then what is your P? 40%. That's how you find your percentage. Okay, so the question would be asked would be what? Either find your A or B or P. One of three unknowns, then we will give you two of them, then you find the third one. Next one. If the number of students taking algebra at LTCC was 420, and next year would be 525, from 420 to 525, right? What is the percent of increase? So what's the increase? Increase would be you minus them would be 105, right? Then they want to find out what's the percentage increase for this one. And we do that P, B, A. Do we know the percentage? We don't. Okay, then what's your B? What's your A? We have three numbers. What do you think? What's your base total? Original. That would be what? 420. What's the percent of increase? Which one is increase? Not the 525. It's this one, 105, right? So we find the P this way. So A over B equals what? P over 100, right? Then we'll do that. 420P equals what? 105.00. You multiply that. Then you divide by 420, right? So your P is what? 25. So that would be what? 25% of increase, right? So we use the basic formula to do that. Then we write our proportion. Then we solve our linear equation, right? Let's see next one. We also solve discount and markup problem. Okay, so say a pair of pens originally cost $52, has been put on the sale for $25, 25% off. What do you think? How much you can get for the discount? How much you can actually pay for it? Okay, so for the formula for the discount, we do this way. Okay, formulas for discount. Okay, we use this second one because discount is what? Your percent times total, right? You want to find the what? Discount amount, right? So your formula would be what? Your amount of discount would be what? That's your discount dollars, right? Equals what? Your percent times what? So that would be your discount percent times your regular price. That's how we do, right? That's amount of discount. How about the sale price? Sale price would be what? Equals your regular price, right? Minus your discount. Is that right? That's how you do it. So let's take a look how we are going to use this for from the second formula, right? Because discount is a portion of a portion. You time the whole, that would be your portion amount. right? So it says for the $52 one, then you get what? 25% off. Then how much discount you can get, right? So it's what? Discount dollars, that's your amount, equals what? Your total, your percentage, 25% times what? Your regular. So that's your discount equals percent times regular price. Okay? Then when you multiply, how do you do it? You actually change the percentage become what? Decimal, right? Move to decimal places to 0.25 times 52. Do you remember how to do the multiplication for the decimals? So you line up them at the back, right? 2 times 50, 5 times, so this one, 50, 25 times 2, 10. Is that right? Then you put it together. Then total, how many decimal points do you need? Right? Decimal places. Here is 2, here is none. Total would be what? 2. Right? So you move here. So that would be the number you are looking for $13 for the discount. But you need to know how to do the decimal multiplication. Then actually, how much do you pay for it? What do you think? For $52, you get $13 discount, so you pay $39. Okay, so that's how we do the discount problems. And how about markup? Right? So for markup is what? Formula for markup. Okay? So say if you have a boutique or you have a bookstore, then if it's coming $100 as a wholesale price, then you say, okay, for a bookstore, I want to mark up for 30%. That means $100, you mark up 30%, $30. So you will put the sale price as $130, right? So that's how we do amount of markup, right? So your markup amount, well, we use this as well. That's the amount equals what? Your markup percent times your base, right? Original price. Okay? Then say $100, your markup would be 30%. That would be $30, right? Then what's your sale price? Then your new price would be what? Your original price, right? Plus your markup price. Is that right? That's how you do it. So let's see some examples. Say a retail store marks up their merchandise by 85% to get their sale price. That means $100, they want to mark up 85%, $85, then their new price would be what? 100 plus 85 would be 185, right? That's what I mean. So if they purchase an item for $150, then they want to mark up for 85%. So what's the sales price, right? So we have to find out what's the markup price first by using this one, right? Amount equals percent times B. So the markup price would be what? A equals your percentage times your total base, right? Then you will change your percentage become what? 0.85 times 150. Then you do your decimals. Then that would be $127.50. Okay, so that would be for $150. The merchandise they want to mark up for $127.50. So what's the selling price? That would be $150 plus $127.50. So that would be what? $277.50. Right? Okay, that's how we use percentage. Let's do some mixture problems on your page 53. Okay, this portion you might get confused. Okay, then let's see how much we can do. First one, Galen sold 810 tickets for his church's carnival for a total of $2,820. So there are 800 tickets, right? How much is sold? 2,820 total. Children's tickets cost $3 each, and adult tickets cost $5 each. How many children's tickets and how many adult tickets did he sell? So if you are managing this carnival, at the end of the day, you find out you have 810 tickets sold. Then you got $2,820. You wonder, right? How many actually for kids, how many actually for adults? Then $3 per kid, then $5 per adult. Okay? So if you have a lot of kids, then next year you may, promote more popcorns, more games, right? But at the end of the day, you only know, okay, I have 810 tickets, $2,000. Okay, so the question was, how many children's tickets and how many adult tickets did he sell? So, how many things we need to know? 2 things. How many children's tickets and how many adult tickets? 2 things, right? How should we start? We say first, what do? You will identify things needed with how many variables? Just 1 variable, right? Then actually we say we need to know how many number of children's tickets, right? And number of adult tickets. That's what we need to know. But we can only use 1 variable. So how about we just say, oh, put the children as X. Then what happened to the adults? You cannot use Y, but You know total is how many? 810, right? Part of it is for children, part of it is for adults. So adult tickets will be what? Take X away from 810. Would that work? Right? Then second one, we say write the equations. So first we identify each one with how many tickets here, right? Then next one we have to write it for total number somewhat in the 2020, right? If you have children, for each children, each one is $3. If 10 of them, that would be $30, right? If 100 of them, how much you will get? 300, right? How did you get that? So for each one times how many tickets you have, then that would be the total amount, right? Then we don't know for children's ticket, actually it's X. For each one is $3, what do you think you should get? How did you get 30? 3 times 10. How did you get 300? 3 times 100. If you have X, how much you should have? You should have $3X. Right? Depending on how many X's you have, that would be the total amount you will get for the children. Then same thing for the adult. If it's 10 of them, you will get $50, right? If 100 of them, you should get what? $500, right? How do you get that? You times it, right? Now, how many tickets for the adults? If it's X, that would be 5X. But for the adult, it's 810 minus X. Then how much money you should do? You should get, right? You multiply them. So you should do 5 times 810 minus X. Is that right? So for X children, you get 3X. For 810 minus X adults, you should get this. Then how much total you should get? 2,820, right? That means from the children and from the adults. That's the total. So how do you write your equation? So you should write 3X plus 5 times 810 minus X. You should get what? 2820. Is that right? That's how you mix things. Portion of it for the kids, portion of it is for adults. But end up, you will have a total. That's how you do your equation. Mix them up, right? Then, do we have a linear equation? Can we solve it? So, we distribute them. So that would be 3X. 5 times 810 would be 4050, right? Minus 5X equals what? 2820. Then we solve our linear equation. Combine like terms. Negative 2X plus 4050 equals 2820. Then get a variable to one side, get number to another side, right? So we have negative 2X. Then this one, you cannot minus the big number from the small number. You need to do what? You need to use the big number minus small number, right? Line them up, 2A. Okay, 30, 1230, right? Then the big number is the negative, so you should have negative 1230, right? And to solve X divided by 2, so your X is what? 615. 615 of what? Dollars? Goats? You need to go back and check. Okay? So here says X is what? Children's ticket. So that means what? You have so many children's tickets. Right? Then how many for adult? Adult tickets will be, total is how many? 810, right? So you do 810 minus 615. So that would be how many? 195 tickets. So 195 tickets for adults, right? How do you know you are doing right? How about we check? How do you check? Because each kid is $3. So you do what? 615 times 3 of them. $3. Total would be what? You will get $1845, right? Then for adult, each one is $5. You have so many tickets sold. So you multiply them. That would be $975 you will get. Then you add them together. What do you have? 1845, 975. You will end up 2020. That's how you check. Does that make sense? It will take you a while to sink in, okay? That's how we mix things with two different things. And mix together, we have a total, okay? You can only use one variable, so you identify things needed. Doesn't matter 1, 2, 3 things, right? Like we had 4 numbers, we still can use one variable to identify them. Then you write your equation. Writing equations is very difficult. Okay, not as simple as it looks. All right, then you have to get a total according to the situation. This one is for the kids, money you get in. This is the money you get in for adults. Then total you will have that much. So you can write your equation this way. Then you solve it, you can do that part. Right? Let's look at another one. Second one. Henning is mixing raisins and nuts to make 10 pounds of trail mix. Raisins cost $2 per pound and nuts cost $6 a pound. If Henning wants his cost for the trail mix to be $5.20 a pound, how many pounds of raisins and how many pounds of nuts should he use? So, say if you want to mix this trail mix, total 10 pounds of what? Trail mix, right? Then you know it will be, you are going to mix with them what? Raisins and nuts. Nuts usually it's more expensive, right? Then raisins is $2 per pound, nuts is $6 per pound. So if you want to sell trail mix, 10 pounds of trail mix, you cannot just use raisins for $2, right? 10 pounds only worth $20. Nuts $6, it will worth $60. So if you put too much nuts in there, that's more expensive, right? Then you want to average like what? A about $5.20, okay? So it's around $5.20 worth for the trail mix. If you put a raisin, 10 pounds, only worth $20. If you put the nuts, $6 per pound, 10 pounds, that will cost you $60. But if you want to sell for $5.20 for 10 pounds bag, you want to have equivalent values, you cannot just sell raisins for that kind of trail mix. Nobody will buy it, right? If you put all the nuts in there, then it's costly for you, right? So what do? Right? So your thinking is this way. Total worth of what? Raisins and nuts should equals to what? The total worth of the mix, right? Trail mix. Right? Trail mix total worth is what? $5.20 per pound. 10 pounds should worth what? $52, right? So you are going to mix those raisins and nuts. Then how many pounds of raisin you will use? How many pounds of nuts you will use? That was the question, right? So how should we start? Identify things needed with one variable. How many things we need? We need to know how many pounds of raisins, then how many pounds of what? Nuts, right? That was the question. But we can only use what? One variable. So I say, okay, I use X for raisins, so many pounds. So I cannot use Y for the nuts. What should I do? We have to use the information we have, right? To get some kind of X for nuts. But you do know their total together should be what? 10 pounds. Is that right? So if raisins is X pounds, then remaining should be nuts. Total add up 10, right? So if you take X pound away from the 10, that would be the nuts. When you add them together, it's total 10 pounds, right? Then we say, how do we write our equation? You see, total worth should be the same. Nuts and raisin combined should be the trail mix. Then trail mix is worth $52. Then how about raisins and nuts individually, right? Each pound of raisins is $2, right? $2, 1 pound, just like here, right? If $2 1 pound, right? 1 pound would be $2. 2 pounds would be what? $4. How did you get that? You times it, right? If X pounds, how many dollars? That would be 2 times X. Is that right? So for the nuts, each pound is $6. 1 pound would be what? $6. 2 pounds would be what? $12, right? You multiply them. Now it's how many pounds of nuts we will have? 10 minus X pounds, right? If X pounds, you use 6X. But for the nuts would be what? 10 minus X, right? So that would be what? $6 times 10 minus X, just like here. Same concepts, right? Then the total worth should be the same for individual two or mix them together, right? So that's the cost for the raisins. That's the cost for the nuts. Total worth will be what? You add them together, right? Should be what? $52. Are we good? Can we solve it? Right? So we have a linear equation. Solving it, you can do it. Right? You distribute. So 2x plus 60 minus 6x equals what? 52. Right? So that would be combined like terms. Negative 4x plus 60 equals 52. Then you minus 60 on each side, right? So you have negative 4x equals what? Negative 8. Then you divide it by negative 4. You have x is 2. What does 2 mean? $2, 2 goats? You have to go back. Take a look. What's your x? Right? So your x is what? Number pound, how many pounds of raisins? That means you have what? 2 pounds of raisins. Then how many pounds of nuts do you need? Total 10 pounds, right? And 2 pounds for raisins. You will have what? 8 pounds for nuts. Is that right? How do you know you are doing right? Can you check? How? Okay, so 2 pounds of raisins, how much it would cost you? How many pounds you have? Right? $2 per pound, 2 pounds. So for raisins would be $4, right? Then how about for nuts? Each pound of nuts is $6. A pound would be what? $6 times 8, that would be $48, right? It's worth. Then how much is worth total? $52. Is that right? How many pounds we have? 10 pounds. That's how you check. Are we good? That's how we mix things together, but the total worth should be equivalent, right? As you separate them or you mix them. Let's see, next one. Couple is mixing Kona beans and the Maui beans to make 25 pounds of coffee blend. Kona beans cost couple $12 per pound and Maui beans cost $18 per pound. How many pounds of each coffee bean should couple use for his blend to cost him $14.40 per pound? Okay, so total, he wanted to, if he has a coffee shop, right? So total he want to make 25 pounds of coffee bean, okay? Which, this is a mix, right? Which including what? Kona bean and Maui bean, right? Kona bean seems cheaper, would be $12 per pound, right? Then Maui bean is more expensive, is $18 per pound. So he doesn't know how many pounds he's going to use for Kona and how many Maui, right? Then when he mixed together, he wants kind of value is what? $14.40 per pound. If he used all the Maui beans, then that would be more expensive for him, then Kona bean maybe, it's not as taste as, he would like. So how should we do that? Then the whole concept is what? Total worth of Kona bean and Maui bean should be same thing as the total worth of what? The mixed bean, right? So how much it would worth total supposed to 25 pounds for $14.40 per pound. So you do $14.40 times what? 25 pounds. So it should be worth how much? $360, right? That was the plan you would like to do. Then how many Kona beans does he need? How many Maui beans does he need? Same thing. We say, okay, for the things we don't know, we use what? X. How many things we need to know? 2 things, right? So you say, okay, number of pounds of Kona bean equals what? X pound, right? Then how many pounds of Maui beans you will use? What do you think? Total how many pounds? 25 pounds. So you take X pound away, that will be 25 minus X, right? Then it should worth the same. So you write your equation. How much it worth for the X pound of Kona bean? Each pound is $12. So $12 times X. That would be how much it's worth, right? Individually, that's for Kona beans. How much for Maui beans? So $18 per pound. How many pounds? 25 minus X, right? Then total issue worth what? $360. Right? Then we solve our linear equation. You can do it. So you distribute. So that would be 18 times 25 would be 450 minus 18x equals 360, right? Then we combine like terms. Negative 6x plus 450 equals what? 360. Then what do we do? Minus 450. That would be negative 6x equals what? Negative 90, right? Then you divide by negative 6. X is what? 15. Then you have to answer the question. What is your X? Is it dollars, golds, birds, whatever, right? No. You have to go back, check. Means what? 15 pounds of what? Kona bean. Right? Then how many Maui beans you will use? Total 25 pounds, right? So that would be what? 10 pounds because 25 minus 15 equals what? 10. 10 pounds of Maui beans. Right? Then how do you know you are doing right? Then you check it. So how much is worth for Kona bean? 15 pounds. Each one is how much? $12 a pound. So 12 times 15. It's worth $120 for Kona beans. How about for Maui beans? Each one is $18. You have 10 pounds. Total will be what? $180 worth. If you put them together, how much is worth? $360. That will be your total worth of the mixed beans. Is that right? That's how you check. Okay? It might take you a while to sink in and to connect how to do mixture problems. Practice some, and with homework that will help. Okay? So that would be our sections 3.2 and 3.3.